have a hemispherical surface like this. The surface is frictionless, and at the top there is small mass m, point mass, and it has been just given a very gentle push. As a result, it slides, and at this point it loses contact with the surface. We are asked at what angle theta this is going to lose contact with the surface. So this is a case of a non-uniform circular motion. As it is coming down, it will losing on the potential energy, kinetic energy will be increasing, speed will be increasing, and at one angle theta this will lose contact with this surface. Now let's say first of all we find what is going to be the speed of this at this point. If we call this as point A, we call this as point B, and let's take this as reference level. We take this as reference level. So to find velocity in vertical circle, obviously we use conservation of mechanical energy principle, that is MEA is equal to mechanical energy at B. It means potential energy at A plus kinetic energy at A is equal to potential energy at B plus kinetic energy at B. The mechanical energy, that is potential energy over here, is mgr, this is r, radius of the surface is r, plus kinetic energy, speed is 0, so it is 0, half m0 square is 0, is equal to potential b, that is what is this height? This is r, so this is r cos theta, this is r in this right angle triangle, this is right angle, hypotenuse is r, so this you know this is going to be r cos theta, so it is mg r cos theta plus half m vb square. This goes over here, so this comes out to be mgr 1 minus cos theta is equal to half m vb square. M and m they get cancelled, so it is 2gr 1 minus cos theta is equal to vb square. So vb square over here is like this. Let's keep it as vb square only, because we know ultimately we have to find the centripetal force, which is mv square upon r. V square will be required. So there is no use first we find the square root and then we square it again. And then now once it is known, so we know that is centripetal force which is required over here toward the center. Now centripetal force which is requirement of centripetal force is equal to mv square upon r. 1 minus cos theta upon r is equal to 2mg 1 minus cos theta, r and r will get cancelled. So centripetal force is like this. Now we shall be looking for the forces which are along the radius and which can meet the requirement, this requirement. The forces which are acting on this body at this instant, one is mg, the second is the normal reaction, normal to the surface, perpendicular to the surface. Obviously this will pass through the center only. This is already aligned along the radius. This angle we have taken as theta. This is already aligned along the radius, so will not disturb this force. This mg is going to be broken, and so that one of the component is along the radius, that is this way, the other is going to be in this direction. If this angle is theta with the vertical, this and this side they are two parallel lines, this and this is parallel. So if this is theta, so this is also going to be theta. So if this is mg, so this component is going to be mg cos theta. And perpendicular to this is going to be mg sin theta. Obviously this will be responsible for the tangential acceleration of the body, what we have done earlier also. So along this way, if we see, that is equation is going to be mg cos theta minus n. That should be equal to this force, net force, it has to towards center, so it means this force should be greater than this normal reaction, and mg cos theta minus n, that should meet the requirement mv square upon r. Now over here we have assumed, we have taken a particular case where it has just lost contact with the surface. When it has just lost contact with the surface and it is just still moving in the circle, so it means all the concepts of circular motion, they will still be applicable, because it has just lost contact with the surface or it is just in contact with the surface is one and the same thing. So normal reaction, it has just become equal to 0. When it has just become equal to 0, and we are talking about this particular case only at this angle. Before that, this equation is very much applicable. But at this angle, this normal reaction has just become equal to 0. When the normal reaction has become equal to 0, then it means mg cos theta minus 0 is equal to, for this particular angle theta, when it has just lost the contact, then over there for this particular angle theta, the requirement is, that is central force is 2mg 1 minus cos theta. So this is mg cos theta minus 0 is equal to 2mg 1 minus cos theta. So this comes out to be mg cos theta is equal to 2mg minus 2mg cos theta. So it means 3mg cos theta is equal to 2mg. mg and mg, that is not equal to 0, so we can cancel it. So cos theta comes out to be 2 by 3, or theta is cos inverse 2 by 3. We get the answer. If it is asked at what height it loses contact, obviously at this height it is going to lose contact with the surface. And what is this value? If this is r, so this is from here to here is r cos theta. So at what height it is going to lose contact? This is going to be r cos theta. What is the value of theta we have got? Cos theta we have got, that is 2 by 3. So it is 2 by 3 r. So h is equal to 2 by 3 r. This body is going to lose contact with the surface.